Hi guys, welcome to my channel and welcome to the most expensive build on this channel I did so far. It's a Swift S1 with 3.3 meter wingspan. Manufacturer is Tomahawk from Germany. The plane is an electric powered full aerobatics glider, and as you can see I ordered it in complete white color. Normally Tomahawk models are already pre-painted from factory, but I wanted to have it in all white so I can do my own livery. Livery video will follow later. And I also did some custom parts which I will show you through this video. If you have your own projects and need custom parts, I highly recommend you to visit PCBWay.com. PCBWay.com offers you worldwide service for CNC machining, 3D printing, and PCB manufacturing. Check out their website. They offer great products and great service the whole year. So check their website and enjoy the world of PCBWay.com and all the custom service they offer. So now let's jump back into the video. Enough talking, let's have a look at the build steps and enjoy the video. First of all, I removed the pre-installed spinner. This is a turbo spinner which helps to cool the motor. Then I also had a look at the prop, which is a 19 by 13 full carbon fiber prop, which is finished really pretty nice, and it's super lightweight and also pretty stiff. Then there is a rubber ring which helps to fold the prop automatically to the fuselage, which is a nice feature I really like. So then I started to work on the mount for the servo for elevator and rudder. I had to check the position to make sure that I didn't get in trouble with the position of the cockpit. So it was the position you can see here, but the fitting wasn't that good, so I had to work on the edges all around on the part to make it really fit nice and clean, and did also some more modifications. What I also removed is the front end, you can see here, just to make it possible to put the battery underneath the servo mount. So like this I am able to change the position of the battery to adjust the CG of the plane. I wanted to have as much as possible free movement of the battery to get the perfect CG, no matter if I will install a cockpit or I will put in a pilot doll or whatever. Then the servos didn't fit, so I had to rework the openings for the servo to make the KST servos fit. And the finish of the top plate, which is fiberglass, didn't look nice from the factory. So I wanted to change this too to make it look nice and clean. Sanded everything down on the surface. Then I took 1.5 millimeter plywood and designed a top plate to cover the, in my opinion, bad looking top plate, just to make the installation look way cleaner than it was from factory. So I had to cut it out with a Dremel. That works pretty well. It's not the fastest solution, but it actually works. Then I used 80 or 60 grit sandpaper to again sand the top plate and the bottom side of the custom plate, just to glue it perfectly together. For this I use super fatty glue, which is a great glue to connect wood, carbon fiber, fiberglass and other materials. It's a pretty thin glue and it sticks pretty well, but it's not as fast as CA glue, so you have enough time to put the parts right together. Then I had to lift up the servos a little bit just to make the battery still fit underneath the servos. So these small plates you can see here, which I'm sanding and cutting, these are made to lift the servos about, again, 1.5 millimeter This helps to get enough space underneath the servo to go underneath the servos with the flight battery. Then I sanded everything again to perfect shape. Also again the servos and top plate I sanded with 600 grit to make it look nice and smooth, and I'm really happy with the finish of the final customized servo mount. Then the small parts to lift the servos, I also glued them on with superphatic glue and used some clamps to put them in place and let the stuff cure. Then it was again a little bit tight, but it was okay for the servos. They fit like this, and the installation looked pretty clean. I also used rubber mounts and custom screws which are a bit bigger in diameter and fit perfect without any other mount material. Pushed some holes to mark the position for drilling and used a nail to increase the holes, and then the plate was prepared for drilling and drilled first 1.5mm holes, then 2mm hole which works perfect for 3mm wooden screws, and like this the finish of the plate is nice and clean. Then I screwed in the screws that fitted all perfect, and I was really happy with the solution I did here on the elevator and rudder servo. And it was time to glue the mount into the fuselage. I prepared also the fuselage with some sandpaper, 80 grit sandpaper, to get maximum grip for the epoxy. Just had to put it in, go to the marking in the fuselage to have the right position. Then I also checked if the mount is really leveled. That looked all good. And this is the position how the installed servo mount looks. Then I added some more epoxy at the edges just to make the connection stronger. And second point is it looks a bit cleaner if you close the little gap between the top edge of the plate and the fuselage itself. Then these are the rods for elevator servo. And I didn't like the finish of the factory rods, so I sanded and cut them to a nice end shape like this. They look nice and clean, and that's what I wanted to have during the whole build, to have all parts as perfect as possible. Then I put it on the rod end to get the rod build for the elevator. There was also the idea for a counter nut, but I don't use it. I prefer to use Loctite to keep the rod end in position. Then I sanded the rear opening for the elevator rod. There was a lot of sanding needed just to give the rod as much space as possible, because I wanted the maximum angle which is possible on positive elevator. So there was some limited space I didn't like, and I reworked all the stuff to give the whole elevator rod as much space as possible. Then I did the first test installation, screwed in the screw, but the screw also was too long, as you can see a bit here in the middle of the picture. The screw also was too long, so had to cut down about 2mm of the screw to give maximum space for elevator rod. This is important for crazy aerobatic maneuvers which need as much rudder as possible. Then I used XPS foam to add it to all the epoxy I used to glue in plates and other stuff. Also the elevator rod is with modified epoxy. This XPS foam adds a few improvements of the epoxy. One is that it's a bit thicker, so if you put on epoxy then it's not that liquid, so it's easier to keep the epoxy in place, and it also looks a bit nicer if it's visible, in my opinion at least. So I like the look of the epoxy like this, and perhaps it gets also slightly lighter because of the foam integrated in the epoxy, but I think that's not really a big deal, but it's more about the look and more about how thick the epoxy is. So it's easier to work for glue spots like you can see here on the elevator rod. So this helps to keep it on the rod and not dripping down the whole epoxy. Like this, you can work pretty easy on these glue spots. Then put it in first side. It helps to twist the rod and the rod end just to get as much as possible the epoxy inside the tube. Then I put it down to angle position, so also like this, it gives a little more space for the positive elevator. Then I had to sand a little bit between the elevator and the horizontal stabilizer, just because it scratched a bit, and like this it was nice and clean. Then reinstalled everything, did a function check if everything fits as it should, and as far like this it all looked good. Used some tape to keep the elevator in 0 position, just to mark the rod where I have to cut it, because the rod is too long from factory. It's a carbon fiber rod about 8 millimeters thick, and this has to be shortened to make it fit to the servo installation position. Then I cut it to the right length, also using my Dremel, sanded it to make the tube end look nice and clean. Then an important step is to drill a hole. This helps to avoid any overpressure if you glue the second end of the tube, because if you push in the rod end and the thread with that much epoxy on it, you get overpressure and you won't get the glue inside the tube. So very important to drill a hole and then add the whole thing and get it into the tube. Like this, you have no issues to get enough epoxy inside the tube and get a perfect result and a nice glue spot. Here I wanted to put a perfect centered position, so I did it like this. Then I started working on the vertical stabilizer and the rudder. As you can see here, the finish of the vertical stabilizer, the edge didn't look good at all, so I had to rework this. Also the rudder horns weren't in perfect shape, so I reworked these. Had to cover the rudder with some tape to avoid scratches on the rudder. So like this, I was able to sand the rudder, and also the rear edge of the vertical stabilizer. I sanded just enough material down to get a nice and perfectly straight line. Checked it with the ruler and everything looked good, so I really wanted to have perfect shape. Then the limit of the rudder was the vertical stabilizer, so I had to remove some material around the rudder horn just to give the rudder the maximum angle I can have. So I added about 20 to 25% of rudder angle with this modification. Then the rod for the hinge didn't look good as on the top finish on the rudder, so I removed some material on the rudder to help to get the rod down into the rudder. This looks way cleaner than factory made. For adding the servo horns onto the servos, which are aluminum horns, I recommend to add some grease to make it easier to put the aluminum horns onto the rudder, because sometimes they are really tight, and with adding some grease it's easier to put them on the servos. Then I started to work on the frames of the Aileron and Flap servos. These wooden frames had to be modified to make sure that I also get maximum range for the servos. The servos itself also didn't perfectly fit into the frame. These were a bit too tight, so I had to sand down the frames. Then also the cable outlet on the servo was in the way, so I had to remove some material again from the frame to make sure to not have any load on the servo cable, which can damage your servo cable, and in the extreme case it can lead to a crash if your servo cable gets damaged in midair. Then it looked pretty good. And also the outer edges, I wanted to have them nice and clean. These were pretty rough edges, so I sanded them down so everything looks nice and clean. The bottom side was sanded to get better grip for the glue, and then I thought I was ready for the installation. And for the screws installation, I also used some grease, some molykote. This makes it easier to screw the screws into the wooden frame without using too much force. And then you have a bit two long screws, perhaps 1 millimeter, and this step is very important to sand down enough screw material, so be careful about this. But you can see here is a little gap I had between two layers of the wood, so I had to repair this. Also used fatigue glue, which goes nice through the gap of the wood. Then I pulled in the screw again, and like this the wood was repaired. Then I started to work on the servos for flaps and ailerons. First I had to cut the horns to the right length. For the aileron, which you can see here, I had to shorten it down to only one single hole, and it was also too thick, the servo horn, so I had to sand it down to make the rod end fit perfect on the servo horn. Then also for more angle, I sanded down the servo horn a bit, and like this I have perfect range of the servo, which makes it possible to have really massive aileron angles if needed for aerobatics. This is the flap servo, so there was a longer servo arm needed. Also here I had to sand down the thickness to make the rod end fit. Then also here the rods for aileron and for flaps were not well finished, so I reworked these. Then I did the first installation check, but the holes were too tight for the rod ends, so here I used a file to make them work nice and smooth. So there is zero play still, but a nice and free moving rod end. Then I used Loctite to put the rods, the threads into the one side of the rod end, then sounded the inside of the servo compartment. Like this I checked if the servos are in the right position, then glued them with 5-minute epoxy. Here I don't use the XPS foam because there is only a thin layer of epoxy there. It makes no sense to put on XPS foam. Checked again the position, if the frame is okay for the servo horn, then repositioned everything, cleaned the epoxy excess, and like this the frames are glued in nice and clean. Then remove the servo screws and I was ready to install the servo to check if everything fits. All looked perfect, but as already mentioned, make really sure to get the servo screws short enough to not damage the surface of your wing, because it's a really thin layer and you can crack the top or the surface of the wing pretty quick with a too long screw. Then I added Loctite on the other end of the thread and installed it on the servo, and had the first check if the length of the thread of the rod fits, and did the first movement check. This is the flap servo, so you can see I also can do an aileron mix, so I can go down like this position and I can also go up for aileron mix, so everything looked good. But I still had to remove some material on the wooden frame after installation on the aileron servo, just to get enough space for the rod to not touch the wooden frame. For easy installation I just use crystal tape from 3M, and then I was ready for the installation of the wiring. So I used the recommended cables from Tomahawk, from the manufacturer of the plane, and had to do some modifications here. First I removed the sticker to not get this in the way during putting through the wing. Went through the wing with the cables to connect them with the servos. That was pretty easy installation, no support tools or anything was needed. That was pretty flawless. To keep the connectors together of the servo, I use clear shrink tube. The reason why I use clear shrink tube is that the shrink tube is stronger than red or black shrink tube. I cannot explain you exactly, but it's not the same material, and the surface, in case of rubbing on the shrink tube and things like this, it's really much stronger than regular shrink tube. And the other advantage is, what I like, is that you can see through the shrink tube and have a check what's going on underneath the shrink tube. Then I had to shorten the end of the cable extension, servo cable extension for elevator and flap servo. So I had to take the thing apart, cut it, the extension cable to the final length, and had to check which servo is which position on the connector to not mix up the servos. Then unsoldered everything and prepared the wires to install the connector again. Had to get off the isolation to make it easy for soldering on, and then pre-soldered all the cables. Always twist the cable to get a nice and clean connection, and then resoldered everything to the connector, and also used some clear shrink tube on the positive wires to avoid short circuit between positive and ground wires. Then I shrink tubed everything so it should look like factory, but the shrink tube didn't keep in place. So what I use is Uhu pour glue, just to make sure that the shrink tube cannot move after installation. Then I prepared some foam parts for the wing rod. The wing connection rod was a bit too short, so it didn't fill up the whole gap in the wings. So with these foam parts, I was able to keep the wing rod always perfectly centered. So if you do not extend the length of the rod, it's possible that the wing rod can move to the left or to the right, and you won't have a centered position. So like this, everything looks clean and you have a perfectly centered wing rod. Then it went on with the installation of the cables in the fuselage. First I had to do these frames, make fit, so I had to sand off a bit of material from the fuselage, from the pre-cut opening from the factory, to make these frames sit perfect. Did this for both sides, then marked the position for drilling the screw holes. So the screws are not included in the kit, so you have to make sure that you have some screws flying around, or you go buy some fitting screws. Then drilled the holes with the Dremel, and like this I was able to make a very clean installation. Used black zinc head screws, which give you a perfectly looking finish. And you just have to push in the connector. There is no need to glue it in, so it sits really tight in the frame. So it's just enough to push it in and the installation is done like this. Then it was time to go on with the battery mount. So there is no battery mount included in the kit, so you have to do your own battery mount. And what I wanted is to make it possible to move around the battery to correct the CG if necessary. So there is no need to add some weight. First I did a template out of cardboard, and when I was happy with the shape of the cardboard, I copied the design onto a 3mm plywood plate, and then I drawed the whole thing, cut everything out to the final shape. First I drilled the holes with a Dremel to make it easier to cut the corners with a Dremel. Like this, with pre-drilled corners, it's really easy to cut everything with the cutting disc. Then I use the file again to get the final shape. It's not only the edges to work on, but I also sanded the angles into the openings for the velcros, just to give them enough space to make everything fit. And did a test installation, everything looked good. So I taped all the fuselage around the mount and sanded the fuselage to also here get maximum grip for the epoxy. And also here I used a clear 5-minute epoxy, which works perfect for such glue spots. And first I also just used the epoxy to get the fixed position. Like you can see here, I put the battery on to have some pressure on the plate to keep it in perfect position. Then I added more epoxy, same solution as on the mounting plate for elevator and rudder. Like this you get maximum grip, and in my opinion it looks pretty clean with the added epoxy, which is again with the XPS foam for a nice look. Then I started to work on the control wire for the rudder. It's important that you can still tighten up the rod end, so don't screw it down to the maximum position. Then I had to do the wiring. The wiring you have to do secure installation. You have to pull it through twice, so you have to do a loop. With this loop it helps to avoid movement of the wire during flying when there's a lot of pressure on the wire. So if you have this installation, you're secure that everything stays in place as it should. Then I tried to squeeze the metal tubes by hand, but that didn't work, so I used some stronger tools to push it together, and like this I had a perfect nice installation. Everything looked good, and then I did the first installation on the rudder servo, and the rest of the setup then happened on the rudder side. Had to fix the rudder in center position, so I'm sure that I get the right length of each side of the wire. Did the same technique on the rudder side for the wire. Same check here on the opening, and the holes were too tight also. The angle of the rudder horn wasn't right, so also here I had to open up the holes a little more so I have some play to get the rudder end to the right length. So there is no big deal if you have a slight play on the rudder horn, because you have to pull on the wire anyways. There is always pull on the wire, so it doesn't matter if there is a slightly play. So if you have pull-pull system on the rudder, it works anyways perfectly. Same technique here to finish the installation, and to secure the installation I put it also on some clear shrink tube. Like this you can avoid to scratch the fuselage. Then use some Loctite for the final installation. Same thing with the shrink tube on the servo side. Then went back to the elevator rod. Final installation was also using some Loctite on both sides, just to avoid any play on the whole installation. Also used Loctite on the screw for the horizontal stabilizer. Then took some Oracle vinyl film just to cover the rod, which is for the hinge of the rudder. Like this, the finish looks nice and clean. Then installed the receiver. As you can see here, still the Futaba receiver. During the build I changed to Radio Master TX15 Max transmitter, so Please ignore the switching between the two systems. That's because I changed the radio. Then it was time for installation of the ESC. First, everything was soldered, so I always use 5mm gold bullet plugs for my 6S setups. These work great, and in my opinion it's a really safe electrical contact with no issues at all. You just have to be a little more careful to avoid short circuits, especially with the batteries. Also on the motor side, I had to install 4mm gold bullet plugs to make the ESC fit on the motor cables. I use Hobbywing Funfly 110 amp ESC. First I had to update the software. When I connected it the first time to the programming card, there was information that it's not the current software on the ESC, so I had to do the update, and like you can see here, it connected the ESC, but there was the mention that I had to update the ESC. So I did the update, and the target was to program it by the program card, but that didn't work even after the successful update of the firmware of the ESC. But fortunately, the ESC is also able to be programmed by the transmitter. As you can see here, there is an error. I had no idea what error it is, but I wasn't able to program the ESC like this. So I had to program it later by the transmitter, but for Funfly ESCs it works on every version of the Funfly ESC, so that's pretty easy. Then I wanted to install it with double-sided tape, but that didn't work at all. So I again used the magic Uhu Pore glue, which works great for all such installations, such solutions, and I had a clean installation like this. It's perhaps not the final position of the ESC, just because there is no cockpit installed for test flights. Then I use sticky pads to keep the battery in place, because the wooden plate doesn't give any grip for the battery, so it will slip around. And with the sticky pads, you have perfect grip of the battery, so it cannot go anywhere, and these things last forever. Then it was time to install all the rods, screwed everything with Loctite, did function checks, everything looked good, so started to program all the rudders and also the motor, did also a first check, and as you can see here, the automatic folding system of the prop works perfectly, also the throttle cut of the radio master transmitter. And this is how the plane looks, still all in white. Livery will follow. There will also be a video about the livery. And I'm really happy with the final installation. All looks nice and clean. The first test flights were successful. Videos will follow also from the test flights. This is it for today's video. Thanks a lot for watching. If you'd like to support the channel, leave a comment, leave a like, and subscribe to the channel. So thanks a lot for watching again. See you in the next one. Have a good time. Happy flying. Bye bye.